Hi, Shane. Hi, Shane. Good morning.
Hi, JP. Happy
Happy
New
New.
Year.
Thank you. How are you doing?
I'm doing well. I went back to New York for the holidays, so I just got back down to Tennessee where I live and work. So it's going well. How you doing?
I am good. Thank you. Yeah, I had a good one too. So you live in Tennessee, is it, Shane?
Yeah, I do. It's kind of funny the way things worked out. The company was a spin out from the Albany nanotech facility, but then some of the first funding that came into the company was from the Department of Energy that brought me down to Oak Ridge National Lab and right outside Knoxville. So I moved down about 5 years ago, and I'm still here.
Oh, okay. Okay. Interesting. Hey, Tarun.
Hey JP. Hey Shane.
Tarun, Happy New Year.
Happy New Year. Happy New Year to
Actually,
you guys.
afternoon.
Yeah, I don't know if Bob is going to join. Let me ping him. Yeah, just pinged. I don't know if he's back from holidays. Hi, James.
Hey,
Hey,
yes,
James. Happy New Year.
Happy New Year.
Yeah, so James, do you want to introduce yourself to Shane and Tarun? I think probably, I don't know if you have met them before.
Oh, yeah, no, I think I just first time joining this one. I probably haven't met with the Fox here. So um yeah, my name is James Wong. We used to work at the Jigu, right? We build the active interposer, helped people to put this integrate this chip together in the hybrid um uh package, and also heterogeneous integration. Um and most recently we saw the technology, so we mainly focus on services and consulting, helping people in this in heterogeneous integrations. Um yeah, and before that, my background has both in hardware and software. I've been working in Intel as a design engineer, like early day. After that, I also like work at the uh, Cisco, but more focused on web conferences, more on the software side. I was at the Oracle for some times, and on until recently, I kind of when I work at the G Group, I focus more on the hardware applications. Um, yeah, that's kind of my background. Hopefully, gives you guys some idea.
Yeah, thank you, James. Yeah, Shane is also working in a similar area, heterogeneous integration. He's developing a new packaging technology. Maybe Shane, do you want to share a few thoughts about yourself?
Yeah, sure. Absolutely. Nice to meet you, James. I'm Shane. I'm with a startup called Lux
Yeah.
Semiconductors. We're also doing advanced packaging, and we're doing interposers and substrates, but based on a metal core material. And so we do our, our our primary headquarters is in New York. We do a lot of work out of Cornell, and I'm personally based in Knoxville, outside of just outside of Oak Ridge National Lab. And yeah, we're relatively new. I mean, we've been around for about 4 years now, and are able to make prototype uh, devices, prototype substrates, and are just working with some customers on orders right now, and wanted to get involved in this ecosystem and try to uh, join in any way we can and help and grow the chiplet economy.
Great. Yeah, thank you, Shane. Yeah, Shane did a presentation before we shut down for the holidays, and he showed. So Shane, is that possible to share the presentation that you did?
Oh yeah, I think that should be fine. Yep.
Yeah, I'd like to host it in our Google Drive. So if anybody wants to learn in future, if that's okay with you, yeah, please send it to me and I'll put it in the host Google Drive.
Okay, sounds good.
And Tarun?
Oh, hey Shane and hey James. Yeah. Just to give you a quick update, like I work at Lawrence Berkeley National Lab, and I'm mainly an IC design engineer, and I also do like system level, architecture development and design. I'm just helping, JP and the group to develop an open source a modular system to do, interoperability of chiplets. Yeah, that's about it, to be honest. But yeah.
Yeah, great. Thank you, Tarun. Yeah, so so we don't have any prepared agenda for today, but what I want to do is, since James have joined, and he has a lot of experience in hardware, software, chiplet integrations. I want to go a high level overview with them what we are trying to do. So the where we stand currently is we are trying to develop a platform for a generic platform that can be open source for chiplet or test chip bring up. Right. Initially, we started off with the package for the interoperability package, and then we wanted to have a board for it to bring up board. And we realized that the same requirement exists for across the industry. And we thought, well, why not do a kind of the platform that the bring up platform we are doing, we'll do it generic such a way that it can be used across chips, across companies. Right, and we have three partners so far. I mean, at least two identified. One is actually, oh no, three, NXP, and we have IMEC, and we have Fraunhofer. So Trent is joining in. He's with NXP. We are trying to put. I mean, these three companies are. Fraunhofer Research Institute, IMEC is a research institute, and we are trying to put together a definition of the platform and evangelize this idea during the Chiplet Summit. Right, I think AMAT is also interested in this. So when Poppy is back, I think we should have a call with, I think probably next week or so, with all the participants to define a define a platform that we can present at the Chiplet Summit to gather more feedback and interest. Hi, Trent. Happy New Year.
Hi, JP. Hi, everybody. Happy New Year.
Yeah, Trent, I don't know if you met Shane and Tarun or James.
I know Tarun and James have been on the call previously. Shane, no, I don't believe I've spoken to before.
Yeah, Shane has got doing heterogeneous integration work. Maybe do you want to introduce yourself? Maybe something interests mutually both.
Yeah, I can start since I'm off mute. Hi, Shane. This is Trent Euling. I'm with NXP Semiconductor. I'm in our packaging innovation group, and our organization is actually taking a central role in investigating and identifying architectures for potential chiplet use for our product lines. And so that's been, and I'm heading up that activity here at NXP here in Austin.
In Austin, very cool. Well, nice to meet you, Trent. I'm with a startup called Lux Semiconductors. We're based out of Albany, New York, at the Albany Nanotech facility. I'm personally based in Tennessee, and we're developing and commercializing advanced packaging substrate technology that is based on a metal wafer, actually. And so there's some kind of advantages that you get using that material set, in particular for higher speed RF and thermals. and we have advanced the technology to the point where we can do multi-layer substrates, and are doing prototype runs for different customers at this time, mostly with the DoD, but we'll be turning more towards commercial sectors this year. So.
Oh, great. Thanks, Shane. Yeah, very interesting. I'll probably ping you at some point in time to learn a little bit more about your technology.
Absolutely, yeah. And I think, JP, the presentation that was given a couple weeks ago when I first joined, I think Bobby sent out an email that the presentation may have been included somewhere.
Yeah,
so
should be.
Trent,
Yeah.
you're able to access
Well,
that. If not, I can send you something.
I'll take a look.
Okay, great.
Yeah, Shane did a presentation in this meeting before we shut down.
Oh, okay. I think I missed that one.
Pretty interesting what he's doing. Yeah,
Yeah.
so
If you,
sorry, go ahead.
sorry. No. Just saying, like, Shane, if you can share that presentation, that'll be great. Then I think it sounds very interesting. What we just talked about.
Sure, absolutely, yeah. Yeah, so and today's call, what I want to do is I want to go over what we are building, and then I mean, for some of you it may be a repeat, but for James, I'd like to bring him up to speed. Yeah, so in terms of status, like we'll have a 3-way call or 2-way call with Fraunhofer and XP and IMEC, right? We want to put together a kind of presentation for Chiplet Summit to evangelize this Bringer platform and the hardware and software together, and then I mean, figure out a way for implementing it. Right, that's where we stand. Let me share my screen. So do you see my screen?
Yeah.
Yes.
Yeah, so this is what we are trying to build, right? This is the universal, what we call as universal test chip bringer platform. And if any test chips that you have or any chiplet idea that you have that you prototype, this platform can be used for bring up. So anyway, you need a PCB for the package, and this is that PCB platform. And what it offers is actually flexible power control and clock and everything you need for the DUT to be to put in the functional state and be tested. Right. So what we found across the industry is like all the companies who have been developing this kind of test chip for their IPs or chiplets, they have their own platform. For instance, my company that I work for, D-Matrix, we have our own board, and Blue Cheetah, they have their own board, Cadence, Synopsys, Alpha Wave, and you take any name company and any company in this area, they have their own version of the design, and right, it's if it can be unified, if we all aligned on one platform, then there's a big benefits to reap. So mainly the hardware, software, standardized implementation. So that way we can focus on the DUT part rather than the infrastructure part, right? And so this is the idea, and if we pull together multiple participants who are themselves doing this work and provide feedback or drive this effort, I think we'll have a good effort and a good platform in the industry that everybody can make use of, just like the other open source projects have got a lot of benefits, right? And what you have is actually a common motherboard. And the motherboard have three, all the modules. It has got pluggable modules on the motherboard. Motherboard is like a backplane, if you will. And the first one is actually a Raspberry Pi 4 or 5. Now with 5 came the same footprint. And then that's mainly used for control applications that somebody that runs the Linux on it and control and set up the test on the platform. And second one is FPGA, and FPGA is Tarun and team from Lawrenceburg Lab are contributing to the design. They have several designs done in the past using this Xilinx Kintex design. So Tarun, is that Kintex, right? Oh, sorry, Ortix. So
Arctic 7. Yeah.
the Arctic 7 FPGA. The idea here is that once you put the FPGA can take care of any voltage translation or any protocol translations and interact with the duty in a more flexible manner. We don't have to worry about proprietary protocols and those things or any proprietary custom voltages. And all this can be taken care by the FPGA interaction of the proprietary protocols or this any voltages and then it interacts with the Raspberry Pi for setting up the test, and for FPGA will drive the DUT. And the DUT itself is a big board, 200 millimeter by 200 millimeter. This is to accommodate multiple package sizes, anywhere from, let's say, 10 by 10 millimeter all the way to, let's say, about 70 by 70 millimeter, or in that range. Right? It does not have any intelligence. All the intelligence is outside the DUT. DUT itself will have only a socket and the few components like connectors required for the signals to exit the DUT board. And then all the clocks and power, everything is on the motherboard. And these clocks are programmable, and you see multiple power modules. And the power modules themselves are programmable and can be controlled using the Raspberry Pi to set up a certain voltage and current. And this power can be monitored. And AD attended the call a few weeks ago, and they are actually interested in and contributing to this, designing the power modules. And their power modules looks pretty interesting. They're very compact and also can tunable. The voltages are tunable, and power and current can be monitored. Right. So this is what we have at the high level, what the platforms looks like. And the DUT part, we'll be designing it for the ODSA interoperability chip and the package that we are developing. But this duty can be substituted for anybody's design, and that's something pretty generic. Right. So this is actually what a physical view looks like. And this is actually the kind of internal details, the block diagram of the whole thing. So you have a Raspberry Pi talking to that Cortex FPGA, and there are a set of 40 GPIO pins, which can be configured in SPI I2C and other interfaces. And then Cortex 7 will drive the DUT with, again, the number of GPIOs, which can be configured as JTAG, SPI, or I2C, or other interfaces that DUT may require. And it'll also have an optional PCI 2 interface. PCI 2 interface is for some of the DUTs may require PCIe interface for setting up the CSRs, right? So and then the DUT board itself will have DUT specific things apart from the socket, and then it has a lot of flexible debug capabilities, and it'll also have include a thermal head for temperature testing as well, since it's going to be a test chip bringer platform. Right, and this is our current definition. And Fraunhofer, they are developing a kind of complete SoC, not just that a chiplet for test chip for chiplets. So they actually have a PCI Gen 5. They also have the other interfaces that typically you'll find on an SoCs. And we are trying to define how can we accommodate all this PCI Gen 5 interface that connect to a host and the other interfaces they'll have. I think this can be done by cables and within the same platform itself. And this is where we are. Probably we'll meet next week more to discuss this and how can we accommodate their requests and possibly others. So we'll have a common definition. Right. So James, in this is a high level overview. And as you can see, there's a lot of hardware and software components in this. And yeah, definitely your help will be greatly appreciated since you have done this in ZGlue. Right. Any help you can offer in this direction in terms of platform definition and implementation, it would be great. Yeah, I'll pause here.
Yeah.
Let's open it for discussion.
Right. Yeah. Thanks for sharing this, JP. So essentially, I think that this DUT means more kind of socket board, right?
Sorry, say it again.
You mean this DUT? I think here you shown here. I think like essentially kind of in a way like kind of like the socket board, right? Where
Correct. DUT level is just a socket on it. And then
right.
probably it may have some duty specific, for instance, um, uh, let's say you want some LDO supply that is not on the power module, maybe we can have it, or any kind of clocks, the simple components to set up the DUT. So there'll be DUT specific components which are not there on the platform.
Okay, and for this outcome, I think that you want to come up with a universal kind of like test board that everyone can use, that you hopefully they will be available on the market and one can just buy it off the shelf and use
Correct. That is the idea. Yeah. So if anybody
and
wants
can
to
be,
manufacture and make it available to the community, they're more than welcome. Yeah.
I see, and then they can be interchanged, right? And then for many different companies that way, just for general purpose testing. So
Right.
this is more like kind of like will there be kind of like spec as well? I think mostly focusing on it's more just kind of like actual kind of physical board. I mean, like sometimes this kind of like your Raspberry Pi 4 here, FPGA. FPGA give you I think like a lot of like kind of programmable. I think like based on what you need there. Okay, interesting. And then for the power modules, that can be substituted with some power supplies, right? Is that what is if I
Yes.
understanding? So that can be like
Yes.
providing
Yeah.
different voltage currents and for different testing scenario and timing and things like that.
Correct. So what you're saying is, can we bring external power supply and then use
Right.
it?
Right.
Certainly. I saw some.
That's what we did actually.
Right. It can be certainly done. This want to be more flexible. So if you want to bring in an external power supply and connect it, certainly it can be done. And I saw some paper actually from somebody in the university did similar development like this, and they used a power supply designed from Keysight. So the Keysight has got a programmable power supply, just like how we are thinking about, and that can be controlled using a Python interface or GPIB interface. And the advantage is very precise, and the current can be measured very precisely and controlled. And right, if somebody prefers that type of setup, yes, certainly it can be done.
Okay. And do you have any kind of like I/O for your propping I/O for like for your signal, like input and output, like are you defining those?
What IO? Can you say that again?
The is for your propping right signals, right? So like is that like are you going to define those like pretty much I think like for all this testing you need some way kind of like I/O to put your instrument propping on top, right, and measure the signal input and
What is
output.
propin? Sorry, I didn't understand, James. What is propin? Can you spell it if you don't mind?
It just
think
a
it's
prop, right? It's
probing.
yeah.
Probing, you mean like this?
Yes.
Oh, okay, got it. Okay. Yeah, so yeah, we can have test points, and these are low speed. The what is driving across this the GPIOs are all low speed, right? So it can be certainly probed. And I mean, those are the ideas we need to come up with. What is that we need to offer? Is it just for, let's say if you want probing on some of the interfaces, how do you facilitate it? Is it simple test points, or do we need to go beyond that? Right now, if you see look at the definition of the signals, they are to bring the DUT itself in a state that's functional. We only need low speed interfaces, GPIO, SPI, JTAG, I2C, right, type of interfaces. But this can be easily be probed. But let's say a DUT has got high speed interfaces. Let's say it has got a PCI Gen 5 in case of Fraunhofer, or it can have another Ethernet and other things, and those can be brought out in high-speed connector within the DUT itself. We'll actually have very high speed, high density connectors, high speed, and that can be easily be probed or connect to a scope directly. Just think of it like an SMAs, but SMAs take up more space, but we'll have more high density connectors, yet it behaves like an SMA that we can connect to a scope. Right? Does that answer the question, James?
Yeah. I just want to see if that's something that you will be included here, kind of like in your definition here.
Right. Signal. So that's a good point. Let me actually put that in my notes as well. Signals for probing. Yeah. So I'll include that here. The high-speed signals, connectors for high-speed signals. Yeah. Right. Certainly, those will include that as a part of the spec and give an idea like what can be done, because this will be DUT specific, but there's especially the high speed IOs. But for the signals that we are driving, the probing, we'll provide a probing mechanism either through test points or through let's say a connector.
Right. So with that, are you also including like kind of a standard interface in your board as well, such as like the JTAG, right, or USB or any other things, right?
Right. The USB comes here, but we haven't thought about USB connecting to the DOT. But if required, I think it can be extended. I don't know if Arctic 7 supports it, but if it supports, we can actually have that be driven as a part of FPGA. Is that what you meant, like USB to the
Yeah.
DOT?
Right. How about the JTAG? Are you going to support that too?
Yeah. So JTAG is pretty easy because this actually we have set up 200 generic pins, right? And you can actually choose any pin, any set of pins for JTAG or SPI or I2C. It's just a matter of what we are running on that Arctic 7 FPGA bitstream.
Okay.
And what it would be interesting to have is kind of cohesive hardware and software. For instance, the bitstream for this, that we can flexibly configure the pins for JTAG or SPI or any equal interfaces, and then drive it the software, Linux software stack from Raspberry Pi, so that the JTAG can be excited or stimulated. I think that's where the real value is in terms of open sourcing. A lot of people contribute to that. So we'll have a good library of interfaces and drivers for driving these interfaces.
Right. Is there a software kind of OS kind of like specification? I mean, like you want to be defining here? Like...
No, we don't have that yet, James. But if you can contribute to that, that'll be great. We are thinking about the Raspberry Pi Linux running on it. But if anybody can contribute in that direction, software, drive the architecture, that would be greatly appreciated. Yeah, that's where we need help. I think we have a good handle on the hardware, but the software, we need to kind of nail down the architecture.
Right. There's something I think I usually like the FreeRTOS or NATOS. I think like that typically kind of use right with this kind of embedded OS.
Yeah, I'm kind of somewhat familiar with the FreeRTOS. Right. Yeah, we can certainly evaluate all these options, and whichever gives us the flexibility to, and so a good chance of open sourcing everything for stimulate for duty test.
Right.
Yeah. So yeah, I think one there are some internal development happening in Fraunhofer, which they said they will share probably next week. So we'll hear from them what they want to contribute.
So, and the outcome of this one, are you planning for just kind of like a spec for that physical board, that how it's going to be that kind of like universal? like test print
Yeah,
chip,
good
like
question,
in some
James.
white paper or something like that?
Yeah, good question. From a ODSA standpoint, ODSA will define the specification, platform specification. And we also want to have the implementation done, right? So as a prototype and then demonstrate this in the spirit of OCP. And but if I mean, ODSA is not in the kind of business is supplying this if anybody wants. Correct. It's not really a business entity. It's a more of a spec or collaboration and technical organization. So we want to keep it like that. But if anybody wants to actually take up this concept and provide, we'll be working with certainly the partners. I think Tarun is working with the Fermi Lab, and they have some partners developing the board. And same, right? We may have some few partners who may actually build this if somebody wants to actually order this or want to have that for their own use. But initially, we'll be plan to build something like 10 boards as a proof of concept, one for interoperability, the other for showcasing this idea. Right. And so hope we have more ideas about that. Right. And that's why we want to evangelize this during this Chiplet Summit to see the interest from others. The goal is not just that the white paper or spec, but the goal for us is actually realize the physical hardware for the defined spec.
I see. And then for this one, I think that for that board, I think anyone can take this one and manufacture and build it and sell it on the market.
Correct. Yeah, as long as they actually kind of refer the ODSA, I think this is the same way that OCP works, right? Yeah, the spec is open. If anybody interested in making this available for others, they're more than welcome. Yeah, originally we started off this just for the ODSA, I mean the BOW interoperability package, what you see here. So this package is done. We are raising funds for actually prototype this package. And so the main goal was to actually showcase the interoperability of the BOW PHY interfaces between the D-Matrix and Blue Chip, the first two test chips that we had that came out of the BOW specs. And right, and later actually we realized there was a lot of interest for making it as universal test chip. Anyway, putting a lot of efforts in developing this bring up board, but why not make it something generic so industry can benefit out of this?
Got it.
So that started.
Got it. Yeah, I think this is very helpful. It's very interesting. I think thanks for sharing. I have to actually jump off for another meeting, so I think I for cutting short a lot kind of overlapping meetings. But I definitely I think I will look for. I think I join on the next meeting. Anything I think I probably available on the email. Right, just shoot me email for.
Sure, James. Yeah, thanks for joining. And yeah, any inputs you have, I think it would be great.
Will do. Yeah, thanks, JP and everyone. Later. Yeah.
Thank you. Yeah, let me stop sharing. And are there any questions or any thoughts before we close the call? Okay. Anyway, I think next step is actually sync up, like we discussed before shutdown. That we have I think Boppy will be scheduling a meeting with Fraunhofer and IMEC. So we'll discuss on the next steps about this platform realization and evangelizing this platform.
Mhm.
Meanwhile, if you have any inputs, please share by email, or we can discuss this over next week. I think Bob will be there next week. So Trent, so it looks like you already ordered the FPGAs, right?
Yes, I have them. I have
Oh, you
10
already
of
have
the.
them. Okay.
Uh-huh.
Excellent. Thank you. Yeah. So I think
Yeah,
that's a
and
step.
I think there was some discussion. Through my own fault, I missed the meeting with Fraunhofer and IMEC. But I think There may have been, I think I saw a note, about the Raspberry Pi also. If we need to purchase that as well, I could look into that. I was trying to, I wanted to get something purchased before end of year 2023, since I had some unused spend. Yeah, but of course, hopefully I'll have some more this year, so we can look at what else can happen there.
Sure,
But,
yeah, thank you for your support, Trent.
AJB, the only comment I would have, like on the packaging side, is we oftentimes do multi-project wafer runs, and so and we have our own kind of internal layout simulation design team. So we could come in as a kind of secondary option for the substrate or the interposer in this DUT. Perhaps later on, after the first organic substrate is developed, and we can provide some of our own resources there to support that on the design and fabrication side. It would just be a question of the availability of those chiplets from Lucida and other vendors. So.
I see. Yeah, that'll be great, Shane. We'll confirm the availability, and I think if you can also demonstrate in your platform all this with your metal technology, it'll be very interesting.
Okay. Yeah. Great. Well, we can talk about that as well.
Sure. Would you be attending the Chiplet Summit?
I'm not sure. We have a deadline coming up in February, so I've kind of held off on making the decision on the Chiplet Summit up to this point. So yeah, it's still TBD.
Okay, sure, yeah. Okay, no problem. Yeah, I think we'll touch base on that. I think we need some more discussion about. I think we need to make a formal representation from ODSA to these two companies for making the chiplets available, and I think that's the right direction. Different people want to try different packaging technology, and this kind of platform would facilitate it is actually in the right spirit of ODSA and OCP.
Okay, great. And I assume you will be at the Chiplet Summit?
Correct. Yeah, I plan to attend that. Yeah.
Okay, great. Well, if I do make the decision, I'll definitely let you know, and we can meet up when we're there.
Yeah, that'd be great. Yeah. How about Trent and Tarun? Do you have any plans?
No, I don't think I'll be attending.
Okay.
Yeah, I don't have any plans either, JP.
Sure. Okay. Okay, so let's catch up then next week. Yeah. So meanwhile, I'll touch base with Boppy and setting up meeting with Fraunhofer and IMEC.
Sounds good.
Okay.
Excellent.
Thank you, everyone. Yeah. Talk to you.
Thank you,
JP.
everyone. Yep.
Bye.
Bye-bye.
Bye-bye.
Bye-bye.